Every prediction your model makes carries a hidden number, how confident it actually is.
Probability
It's not abstract math. It's the same toolkit that decides if an email is spam. Mean, variance, standard deviation, Bayes' theorem. For ideas, one toolkit.
That's the whole list for today.
This is episode 4 of Machine Learning from Scratch. Same rule as always, every formula ties straight to code you'll actually use.
By the end, Bayes' theorem will feel like arithmetic, not magic.
Let's build the other half of the math toolkit. Let's start with probability, because it's just a number between 0 and 1. It measures how likely something is to happen.
Flip a fair coin, probability of heads is 0.5. No more, no less.
In machine learning, a model's output is often exactly this, a probability. Predict spam or not spam, and the model is really outputting p spam, a number 0 to 1. Everything after this is about describing and using numbers exactly like that one. Two numbers describe almost any dataset, the mean and the variance. Mean, add every value, divide by how many there are. The average.
10 exam scores summing to 800, the mean is 80.
Variance measures spread, how far values wander from that mean on average. Squared, then averaged, variance punishes big deviations far more than small ones.
A tight cluster of scores has low variance. A wide spread has high variance. Now the number you'll actually see everywhere. Standard deviation.
It's just the square root of variance back into the original units. A variance of 100 becomes a standard deviation of 10 test score points, not points squared. One standard deviation from the mean covers about 68% of normal data.
This single number is how models quietly decide what counts as normal versus an outlier.
Plot enough real-world measurements and you keep seeing the same shape, the bell curve.
That shape is the normal distribution.
Centered on the mean, spread controlled entirely by the standard deviation. Heights, test scores, measurement errors, an enormous amount of real data looks like this.
Many ML models quietly assume your data behaves this way. Now you'll know when that's true. Here's the formula that changes how you think about probability forever. Bayes' theorem.
It answers one question. How do I update a belief after seeing new evidence? Start with a prior belief, add evidence, get an updated, smarter probability. P of spam given free equals P of free given spam times P of spam over P of free.
This exact formula is the entire engine behind naive Bayes spam filters.
You will never compute these by hand. Pandas does it in one line.
df.describe, hands you count, mean standard deviation, min, and max instantly.
NumPy backs it all up, np.mean, np.var, np.std on any array. One line, df, score, .mean, the entire average, computed for you. Every summary statistic today is a single method call away. Here's why this episode exists where you'll actually use this. Feature scaling subtracts the mean and divides by the standard deviation. Every single time.
Naive Bayes classifiers are Bayes' theorem, applied directly to real text.
Confidence intervals, hypothesis tests, anomaly detection, all built on this exact foundation. You won't escape these 4 ideas anywhere in this series. Let's lock in the mental model before we move on. Probability, how likely something is, a number between 0 and 1. Mean and variance, the center of your data and how spread out it is.
Standard deviation, variance, back in real units you can actually reason about.
Bayes' theorem, updating a belief the instant new evidence shows up.
That's genuinely the whole toolkit. You now have both halves.
Let's use it once, start to finish. 30% of emails are spam. That's our prior belief. 60% of spam emails contain the word free. Only 5% of real emails do.
Bayes' theorem combines those into one number. The probability an email is spam, given it says free.
Work through the math and you land at roughly 84%. That is genuinely how a spam filter decides what to flag. Quick look at where this fits in the bigger picture. Episode 5 starts building real models, linear regression from scratch.
Everything from vectors to Bayes' theorem feeds directly into that one episode.
This is pure machine learning, start to finish, no detours into deep learning. Episode 5 is linear regression, your very first trained ML model. Cost functions, gradient descent, and scikit-learn built 2 different ways.
Everything from vectors to Bayes' theorem lands directly inside this one episode.
Subscribe so you don't miss it.
Before you go, here's your challenge task for this episode.
10 exam scores: 72, 85, 90, 65, 88, 76, 95, 60, 82, 78. Task 1. Compute the mean and standard deviation using NumPy. Task 2. Run pandas describe on the same data and compare the numbers.
Bonus round. 30% of emails are spam.
60% of spam contains the word free. 5% of real mail does too.
Use Bayes' theorem to find P, spam given free. Pause the video right now. Open your editor. Try it yourself first.
The full solution, every line explained, is in the GitHub repo. Post your answer in the comments. I read every one. Probability and statistics aren't a detour before real ML. They're the language every model already speaks.
You now own both halves of the math toolkit.
Episode 5, Linear Regression from Scratch, drops next. Subscribe. Comment if Bayes' theorem finally clicked.
I'm Majas. This is CodeToAGI. Let's build.